All right, welcome to The Explainer. Today, we're diving into a world where the crime scene isn't a room, but a hard drive, where the clues aren't fingerprints, but tiny fragments of code. We are getting into the absolutely fascinating field of computer forensics.
I mean, really think about that for a second. A physical crime scene, it's got fingerprints, footprints, actual stuff you can see and touch. But a digital crime scene? It's just a stream of ones and zeros. Sometimes it's on a hard drive, but sometimes it's just sitting in a computer's volatile memory, which means it's invisible, it's fragile, and it's gone forever the second you hit reboot. So how on earth do you investigate that?
Well, that's where computer forensics comes in. It is the special set of skills built to solve this exact problem. It's really part art, part science. This super methodical process of capturing, preserving, and analyzing digital breadcrumbs to piece together exactly what happened.
And let's be perfectly clear about how serious this is. We're not just talking about finding a deleted file here. The evidence these folks uncover has to be so solid, so completely untainted, that it meets the same incredibly high legal bar as DNA evidence. The chain of custody, how it's preserved, every single step is absolutely critical.
So, before we get into all the cool tech, we've got to understand the rules of the game. See, for any of this digital evidence to be useful, it has to be allowed in court. Let's break down what that actually means.
In any trial, you've basically got two flavors of evidence. You've got direct evidence, which is super straightforward. Think an eyewitness pointing and saying, "I saw them do it." But then you have circumstantial evidence, and this is where a lot of digital forensics lives. It's not one thing that proves the case. Instead, it's a bunch of facts that when you put them all together, create this powerful story, this strong inference. A suspect's web search history doesn't directly prove they did it, but boy, it can build a pretty convincing case.
Okay, so imagine this. A digital detective spends weeks, maybe months digging and finally finds the smoking gun, that one crucial piece of data. And then they get to court and the judge says, nope, inadmissible. It gets thrown out. It happens all the time. So what could possibly go wrong?
Well, there are three main tripwires. Evidence might get tossed if it's prejudicial, meaning it unfairly biases the jury. Or, of course, if it was obtained illegally without a proper warrant. But for digital forensics, the biggest, most common hurdle is proving that the evidence is reliable.
And this really gets to the heart of the whole problem. Digital data is always changing. The information in a computer's active memory, its RAM, is designed to be temporary. So if an investigator can't prove, beyond a shadow of a doubt, that they captured a perfect copy without changing a single bit, a judge can just say, sorry, it's unreliable. Overcoming that is, without a doubt, the single biggest challenge they face.
So how do they do it? How do they combat that challenge of unreliability and meet those crazy high legal standards? They follow an incredibly rigid, step-by-step process. This is the playbook for building a foundation so solid that no courtroom can tear it down.
It all boils down to these three stages. First up, acquire. And rule number one is you never work on the original evidence, ever. You make a perfect, bit-for-bit copy, an exact clone, sometimes called a forensic image. This is so important because it saves everything, even data a normal copy-paste would destroy. Then, stage two, analyze. All the detective work happens only on that verified copy. And finally, you write the report where every single step you took is documented in painstaking detail. That's the process that turns messy, temporary data into rock-solid evidence.
Okay, now we get to the really fun part. We know the process, but what are these investigators actually looking for? What's in their digital toolkit? So during that analysis phase, they use all sorts of powerful tools. They're scanning for malware, they're hunting for encrypted or hidden files, and they're digging into two areas that are often absolute goldmines: a user's web history and their so-called deleted files. A person's search history is basically a window right into their brain. For an investigator, it can be the key to proving someone's intent or showing that an act wasn't random but was actually planned out. It tells the story of what they were thinking, what they were researching, and what they were planning to do.
And this is not just some theory. I mean, think about this real-world example. Search history has been used in actual court cases to show that a suspect was using mapping tools to look up the exact remote location where a victim's body was later found. It's chilling, and it's incredibly powerful circumstantial evidence.
So what about those deleted files? This is probably one of the biggest myths in all of computing. See, when you drag a file to the recycle bin, you're usually just doing what's called a logical deletion. Your computer basically just hides the file and marks the space it was using as available. Think of it like this.
It's like removing a book's card from the library catalog. The book itself, the data, is still sitting right there on the shelf. Physical deletion is when you actually shred the pages of that.
And here's the key takeaway. Because almost everyone only does that simple logical deletion, the files they think are gone for good are often completely recoverable by forensic tools. For a digital detective, finding that data is like finding a suspect's diary after they thought they'd burned it. It's all still there.
So far, we've been focused on all the crime and courtroom drama. But here's the surprising truth. That's not where most computer forensics work actually happens. Not even close. Now here's something that might just flip your whole TV drama perception of this field on its head. Very, very few cyber attacks ever end up in a criminal court. Why? Well, for one, the evidence is often just way too technical for a jury to understand. And trying to track down anonymous attackers across different countries is a legal and jurisdictional nightmare. So if not for court, what's all this work for?
The number one use, by a huge margin, is corporate incident response. When a company gets breached, its main concern isn't the tiny chance of prosecuting the hacker. It's about stopping the bleeding from the massive financial and reputational damage. They use forensics to answer the urgent questions. How did they get in? What did they steal? Are they still in our network? And the most important one of all, how do we fix this so it never, ever happens again? It's all about defense and recovery, not about retribution.
All right, let's pull this all together. What have we learned? We've learned that digital crime scenes are invisible and incredibly fragile, that the evidence has to meet the same crazy high standard as DNA. The ironclad three-stage process is acquire, analyze, and report. We learned that deleted almost never really means gone. And maybe most surprisingly, that the vast majority of this work isn't about putting people in jail. It's about helping companies defend themselves.
And that brings us to one last big thought. For decades, the mantra in this field has been the ones and zeros don't lie. But as we plunge headfirst into an age of deepfakes and AI-generated video, audio, and images, the very idea of trustworthy digital evidence is facing its biggest challenge ever. It leaves us with a critical question for the future. How will the digital detective's work have to evolve to tell the difference between fact and fiction?